Hello y'all and welcome to the Unit 1 Day 2 homework video. We're going to go over pages 3 and 4 in today's video. Now for your teacher, I want you to draw this box up top so that we know that you found this video and we can give you 5 extra credit points. So go ahead and write the box and plus 5. And then on the inside, write how you access this video. So you're either going to say YouTube, if you went straight to YouTube to find it, or if you're subscribed to the channel and that's how you found it, or Canvas. C-A-N-V-A-S. Can't spell and talk at the same time. Alright, so YouTube or Canvas, whichever one you did. If you wrote both of them, please circle that I went to Canvas and found the link that way. And it's time for D-Lunch. I'm busted. Okay, so YouTube or Canvas, your teacher knows how you're accessing these videos, and then you can get 5 extra credit points for doing that. Okay, I want to look at E and F with y'all today on page 3 here. So what we're doing is trying to identify the element. So you are your protons. That's what we need to know. So 3 protons means number 3 on the periodic table, which is lithium. So you can just write the symbol if you want, Li, or if you want to write out lithium, that is just fine. Be super careful with F, because F is not silicon. F is aluminum. 14 neutrons, 13 protons. So this would be aluminum with a mass of 27, okay, because the protons plus neutron is your mass, so that's where 27. But if you have 13 protons, then you're number 13. So this one was written upside down. Just a little bit tricky on you there. Okay, let's take a look to this table. These are important skills you probably had from 8th grade, whether or not you remember them. And I want to look at 5, 6, and 7 with you. So for number 5, the only information we have is that it's atomic number 25. So we find 25 in the periodic table. That's manganese, Mn. We can write that one in there. Of course, it's the hardest one to spell. M-A-N-G-A-N-E-S-E, I think. And here we go. Manganese. And the symbol is big M, little n. Now you'll notice I write in all caps when I write, but capital M, lowercase m. Alright, the capitalization on symbols very much matters. So if atomic number is 25, then for ape man, A equals P equals E. So atomic number, that means protons are 25 and electrons are 25. Okay, I'm going to even highlight that a little bit so we can see that these boxes should always be the same. Okay. Alright, now average atomic mass, the AMU, that's this atomic mass, the decimal number. So for manganese, 54.938. 54.938. Molar mass should be equal. Those two should be equal to each other. Okay. So also 54.938. They're synonyms. Students get them mixed up all the time. But molar mass is equal to the average atomic mass as far as we know right now. We'll learn how to calculate that in a different unit. Okay, so we've got ape, A equals P equals E for ape, man, and man is M minus A equals N. So my rounded mass minus atomic number equals neutrons. So in this case, 54.9, I'm going to make that 55. 55 minus atomic number, which is 25, equals 30. Okay. So when I add these two numbers back up, neutrons plus protons, I should get to that rounded number. Alright, all we know about number 6 is the mass, so we've got to kind of look that up. So 54, we're looking right about here, 65.38, that's the mass of zinc. So that's our element. Excuse me, let me turn that down. So zinc, and symbol for that is capital Z, lowercase n. Zinc is number 30 on our periodic table, which means it also has 30 protons and 30 electrons. Okay, average atomic mass equals molar mass until we start calculating it. So for now, we can just say they're equal. Okay, and then 65.3. We don't want to round that one up, so I'm going to leave that one at 65 for my rounded mass. 65 minus 30 equals 35. Okay, because my protons plus my neutrons should equal my mass. Electrons don't count. What do we know about this one for number 7? We know that there's 16 protons, and that's highlighted. because protons equals electrons as long as we're neutral. That also equals the atomic number. And as soon as we know the atomic number, we know the elements. So number 16 is sulfur, S-U-L-F-U-R, S. Capital S. All right, average atomic mass for sulfur, I'll put that one up here, 32.066. Molar mass would then be the same, 32.066. 32.0 is going to round just to 32, so I'm going to write that rounded mass. 32 minus 16 is also 16. So sometimes they're all equal, that's fine. Protons and electrons have to be neutral, because we're only, or excuse me, protons and electrons have to be equal, because we're only dealing with neutral atoms, but neutrons do not have to be equal. Right, let's turn over to page 4 and look at a couple problems there. First thing we're doing here is drawing Bohr models. So I know y'all learned this in 8th grade. This is review. For phosphorus, number 11, we're going to look at. We know that phosphorus is in group 15, so there should be 5 valence electrons. We're going to put that there. And we know that phosphorus is in period 1, 2, 3. So there should be 3 energy levels. So the first thing we do with the Bohr model is the nucleus. Protons and neutrons. Okay, phosphorus is number 15, which means that it has 15 protons. Okay. On here it looks like the average atomic mass is 30.9, so I'm going to round that to 31. 31 is my average mass minus 15 protons equals 16 neutrons. So that's mass minus atomic equals neutrons. Man. That means I've got 16 neutrons in there. And then, because it's in the third period, right, 1, 2, 3, I need to put 3 energy levels. Let me switch colors. I'm going to go 1, 2, 3. Now, there's a total of 15 electrons there. Remember, the first energy level can only hold 2 electrons. The second energy level can hold 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So that's a total of 10 electrons. And I know because phosphorus is in family 15 or 5A, it has to have 5 valence electrons. So on my outermost level, there should be 5. 1, 2, 3, 4, 5. Okay, let's put them there so we can see them. So if I go back and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 electrons, and 15 protons. So I know I did that one right. Okay, some of these ones are a little bit confusing what we're asking of you. So number 12 says an atom has 28 protons. What element is it? You are your protons. So 28 protons means number 28, nickel. And you can just put nickel, N, lowercase I, nickel. The atom would also have 28 protons, neutrons, or electrons. It'll be electrons, because protons equal electrons, as long as it's not an ion, which we haven't gotten to yet. Number 14, if the atomic mass is 79.94, how many neutrons are there? So we're missing information here, y'all. I don't know how many protons there are, so I have to figure out who has a mass of 79.904. So if we're looking, okay, bromine, 79.904. So I can round that to about 80. 80 is my mass minus protons, okay? And I know if that's my mass, that means 35 of them are protons. So 80 minus 35 equals 45 neutrons. That's my answer. M minus A equals N. And we never want to give neutrons as a decimal. Okay, just like I wouldn't say you are 0.5 of a student. We want to use whole numbers for neutrons, so that's why I rounded that mass to 80. So mass minus the atomic number of protons is neutrons. If I have a mass of this, 55.845, how many protons? First we've got to find that. So who's got a mass of that? Is that iron? It is iron. Oh, I wish I didn't have that memorized. There's better things to do with those brain cells, right? Okay, so that would be iron. And look at, that wasn't even the question. Iron. So how many protons? 26. Whoops, that was the question. How many protons? That is iron. And then how many neutrons? So I'm going to say 55.8. I would round that up to 56. So my mass is 56 minus my atomic number, 26, equals the neutrons. So 56 minus 26 is 30 neutrons. Okay. Again, we're just looking at man, ape man. M, rounded M, minus A equals N. Okay. If a neutral element has 46 electrons, so this is kind of the big word. If it's a neutral element, then ape man works. So A equals P equals E. So if it has 46 electrons, it also has 46 protons, which means we can find it on here. Ooh, palladium. What a special one. 46. Capital P, lowercase d, like that, palladium. And then is palladium a metal or a nonmetal? It's to the left of the transition line, which makes it a metal. You can either just circle it or write the word metal. Okay. And then which two parts of the atom make up the majority of the mass? 99.999% of the mass is in the nucleus. Okay, that's not the question. Okay, so I always tell my students electrons are like earrings. They're on the outside, and it doesn't really change the scale if you put earrings on. So that means electrons do not count in the mass. The things that do count would be your protons, P+, and your neutrons. Okay, so stuff we put in the nucleus up here at the top. Down for here for this one, I'm going to tell you all to look in your notes for these guys. Okay, these are for sure John Dalton. You should know this guy whose name I almost said. That would have given it away. You should know the Rollo man, and you should also know Bohr. So look up your notes for that. If you were absent, then go on Canvas and look up the notes. All right? Well done. Make sure you get your 5 bonus points for getting the information on the first page. Good job.